Okay, guys, welcome back. So you have learned day one, a little bit of day two, and now day three. Today we're going to do some notes. I don't have an official note sheet for you, so you're going to have just a blank sheet of paper out, um, or pay attention. But we're going to be just doing the Unit 11 Day 4 review notes to kind of tie everything together. And then the plan is next week you'll eventually be taking a Canvas quiz on all of this stuff. So this will be just kind of a nice way to tie it all together. Okay, so one of the first things that you kind of started off with was all that vocab stuff. So if you had a circle, all right, and let's say that it's circle A. And let's say that you have a line going through it like this, and we'll call this B, we'll call this C, and then let's put a line through B like so, and then let's put a line through C, but we'll go through another spot on the circle, and we'll call this point D here. All right, so we got A, B, C, and D. Some of the things you're going to need to be familiar with are what's a chord? Well, a chord goes from one point on the circle to the other point. So something like DC or BC or CD, either one of those is fine. They are going to be segments, so make sure you use the segment symbol. Another thing you're going to need to be aware of is like what a radius is. A radius goes from the center to a point on the circle. So something like AC or AB would be a radius. If you also need to know a diameter. Diameter is going to be a segment that goes through the center and goes from one point on the circle to the other. So it's like a chord, but it goes through the center. So BC would be the only diameter. Make sure you use the segment symbol again. Let's see. A tangent line, you're going to need to know what a tangent line is. Tangent line is going to have arrows, and it only crosses the circle in one spot. So that would be this line, which this line needs another letter. So let's give it a letter. We'll call it E. So this line would be line BE. So pretend that E was there all along. So it would be line BE, and you would need to have arrows because it's a line. A secant line is going to be a line that has that goes through the circle in two spots, and it's going to have arrows. So it would be CD, but it's going to have the line symbol above it. Secant and tangent always have line symbols above it. And then we also talked about different types of arcs. So a minor arc is going to be an arc that's smaller than half the circle. So something like CD would be an example of a minor arc. A major arc would be something that's more than half the circle. So maybe something like CBD. Remember, you want to use 3 letters when you do a major arc. So CBD would be an example. All right. And then the other thing we talked about was a semicircle. A semicircle is going to be exactly half of the circle, and you're going to want to use 3 letters for that guy as well. So something like CDB. All right, CDB would be a semicircle because it's exactly half. So those are some of the key vocab words that we talked about. Let's see, what else did we talk about? We talked about how if you have a circle like this and 2 tangent lines like so. All right, so you have 2 tangent lines extending from the same point going to the same circle. And let's say that this one tangent line is 4x plus, let's say 6. All right, and then this guy is going to be 2x plus 2. All right, if you have something like this, the 2 tangent lines are automatically going to be congruent to each other. So you would just set 4x plus 6 equal to 2x plus 2. Subtract the 2x, you get 2x. Oh, that didn't work out the way I wanted it to. Let's make that a 12. All right. No, I lied. Let me start over again. This is what happens when I try and do it off the top of my head here. All right, we're going to do this. Let's say that this guy is 4x plus 2, and this is 2x plus 6. So I apologize. 4x plus 2, 2x plus 6. Subtract the 2x, you're going to get 2x. Subtract the 2 from the 6, you're going to get 4. Divide by 2, you're going to get 2. All right, so you want to set the two tangent lines equal to each other and solve for x. All right. Let's see, what else did we learn? Something else you learned about was area of a sector and arc length. All right, so those are the next two things we're going to focus on. So let's say that you have a circle like so, and let's say that you're given this radius. Let's say it is 4 inches, and let's say that this arc here is, we'll say that it is 80 degrees. All right, so that's what we have. What we're going to do is we're going to find the area of the sector, and then we're going to find the arc length. The area of a sector, remember, you're going to do the arc over 360, and then you multiply it by the area of the circle. Area of a sector goes with area of the circle. Area of a circle is radius squared times pi. So 4 squared times pi. And then you're going to multiply all that loveliness together without the pi, and you'll get your answer. All right, so you're going to want to do 80 divided by 360 and then times it by 16. So let's do that on here. So we've got 80 divided by 360, and then we're going to multiply it by 16. All right, and we can do math bracket. You're going to get 32 over 9. All right. And so we're going to get 32 over 9 pi, and since it's area, it'll be square units, square inches. Okay. Arc length, you're going to do the arc over 360, and then you're going to multiply it by the circumference. All right, circumference, remember, is 2 times radius times pi. 2 times 4 times pi. So you're going to end up taking this 80 over 360 and multiplying it by 8. 80 divided by 360, and then you multiply it by 8, and you're going to get that. We can math bracket. You're going to get 16 over 9 pi, and this time, because it's kind of like circumference, you will not have square units. It's just going to be inches. All right, so that's how that works. Let's see, what else do we have? Remember, if you have something like a circle here, and let's say we have a chord going like this and a chord going like this, and let's say that these two chords are congruent. All right, and you're given, let's say that this chord here is 3x. Let's say that this arc here is 10x. All right, and let's say that this arc over here is 5x plus 40. All right, what we learned in part of the day 2 notes was that if these two chords are congruent, the arcs that they open up to are also congruent. So this arc, 10x, will be equal to this arc, 5x plus 40. The 3x is going to be just kind of excess information. We don't actually need it. Subtract the 5x, you get 5x equals 40, so x is going to be 8. All right, and so that's how you set that up. Let's see, what else do we have? 5, if you have something like, say that you have a diameter here. All right, and let's say that this arc, well, sorry, not arc, this angle and this angle are congruent. And let's say that this arc here is x. Let's say that this arc here is, let's see, let's say it's 4x. All right, and we need to solve for x. What's going to happen is, because this angle opens up to x, and this angle are congruent, that means that this angle will have the same arc, which is x. All right, the angle is equal to the arc. And then once you have that, you'll notice that all three of these arcs together form half of a circle. Half of a circle is 180 degrees. So 4x plus x equals 180 degrees. When you add that together, you get 6x equals 180. Divide by 6, you're going to get 30. All right, so that's something to kind of keep in mind. Let's see, what else do we have? What number was that? That was 5. Okay, for number 6, the last two problems that I want to do, the one of them is going to deal with, let's say that you're given the circumference of a circle is equal to, let's say, 16 pi centimeters. Okay, and we want to find the diameter. What's going to happen is circumference, remember, is equal to either diameter times pi, or you could do circumference equals 2 times radius times pi. Since we're trying to find the diameter, I'm going to use this guy. Circumference, C, is 16 pi, and it equals diameter times pi. If you can kind of tell, you can kind of see the diameter is going to be 16. If you can't tell, we need to get diameter by itself, so you divide by pi. And when you divide by pi, the pi's cancel. The diameter is going to be 16 centimeters. All right, so use the equation, plug in what you know, and then solve for the variable that you need. All right, and then the last thing I wanted to talk about is if you have a picture, circle like so, and let's see, we're going to draw kind of like a cross in the middle here. All right, and let's say that this is a right angle like so. And then let's say that you have another line kind of going through like this. All right, and let's say that this is, let's say 40 degrees. 40 degrees right there. All right, and I think that's everything I wanted. Let me give these some letters. So let's do A, B, C, D, E, F, and G in the middle. All right, and we're going to find a few things. So we're going to find arc BC. All right, and so this is going back to day 1. Remember, if you have a central angle, okay, an angle whose vertex is the center, the angle equals the arc. Since this angle is 40, this arc we know is also going to be 40 degrees. Let's say that we wanted to find arc AB. Okay, arc AB is going to be this angle, is going to be equal to this angle here. What we can do is we could utilize the fact that we know that FC is a diameter. This whole thing has to be 180 degrees. This arc here is 40. This arc here has to be 90. Because this angle opens up to this arc, their central angle, it's going to be 90. So we've already used up 90 and 40. That's 130, which leaves us with 50 degrees for arc AB and 50 degrees for that angle as well. All right, so 180 degrees. I just found out that this is 90 and 40. Subtracted that from 180, I get 50. Let's say that I want to find arc CD. All right, arc CD, you'll notice it deals with this angle here. This angle and this angle are vertical angles. So if this angle is a right angle, we know that this angle is a right angle. And if this angle is a right angle, this arc has to be a right angle or 90 degrees as well, because the central angle is going to equal the arc. All right. If we needed to find something like, let me use a different color. If we needed to find something like this angle here, this angle and this angle that I put red dots in, those angles are going to be equal because they're vertical. If this angle's 50, this angle's 50, which means that this arc over here is 50. All right, and then kind of the last one, if you wanted to find something like arc ACE, all right, you would have to do all of these put together. So you would have, 180 plus another 50. 180 plus another 180, because AD is a diameter, so that's 180, plus 50, you're going to get 230 degrees. All right, so hopefully that kind of helps. You're going to have an assignment soon enough that will kind of deal with these types of problems. So I hope this helped. See you soon.